Okay, we're going to start working on the one of the big parts of the internal, which is the descriptive statistics about the sample. So now we'll be taking like a sample of data, creating a dot plot in a box and whisker plot, like what you're seeing here in this particular picture. And when we've done that, then we have to talk about that sample and analyze that sample. Now, if you did inference in year 12, this will not be new to you. If you did not do inference last year, then this will be somewhat new to you, and you'll need to do some practice, good solid practice around this. So the first thing is that when you talk about the sample, you're going to do it as a comparison of samples for two variables. So for example, we're going to be looking, in this particular instance, it's height, and it's by gender, so female and male. So we're going to be looking at female and male data around their heights. And we're going to do this description as a comparison between these two. So we're going to be looking at centers, which is what is the medians and the means, which is the averages. We're going to be looking at how the boxes shift in comparison to each other. And the boxes are, we basically refer to those as the middle 50%. And we're going to be looking at the overlap, if there's any overlap between those boxes, because all that's very significant around analysis as to how much overlap there is and how similar the variables are to each other. We're going to be looking at spread, which is the interquartile range of the boxes, which is the lower and the upper quartiles. And we're going to be looking at shape, like whether it's symmetrical or it's skewed or whatever. It has tails and anything unusual. So those are the things that we're going to be focusing on. Now in our lesson today, we're going to focus in on shape, and we're going to focus in on centers and shift. So shape, don't spend a lot of time on this. This is pretty straightforward. I've given you a page here where you can just kind of look at what we could use for helping us visually understand what we're looking at for shape. Shape's a bit difficult, but you've got normal distribution, which means it's quite symmetrical, and the data's pretty much focused around the, clustered around the mean or the median. So you've got this mound, it's symmetrical, it's bell-shaped, and so on. You're never going to get a perfect normal distribution, but you might get some data that's somewhat normal and somewhat symmetrical. Right skewed, when you have this tail kind of situation, then wherever the tail is, that basically refers to how you name the skew. So the tail is to the right, then you have a right skew. Data where you have sort of this tail, most of the data is around here, and then you've got this sort of tail thing going on. So that's right skewed. Left skewed, where the tail is to the left. So if you have that, you can talk about that, just mention it. Bimodal, this is not a very good picture because we need another dot there. But when you have two columns that are exactly the same height, those are your modes, the most commonly occurring values. And if you've got two of those that are stacks that are the same, two peaks, then you have bimodal data. Uniform basically means it looks very much like a box. It's very uniform. There's nothing irregular about it. It's not really symmetrical, but it is what we call a box. So it's uniform. Triangular almost never happens. Irregular happens all the time with a fairly small sample. You will get this sort of irregular, data that's spread out, and you've got stacks all over the place, and there's no real pattern to this. And so this is how you kind of talk about shape. And sometimes it's useful to take your dot plots and your box plots and sort of just do this little frequency thing around it to sort of get a sense of what the shape looks like. So then you talk about it and you do it as a comparison. So I've done this one up. There's a little bit in here already. Descriptive statistics must be written as a comparison. So I noticed that. And so if you're going to talk about shape, you've got to talk about how one compares to the other. So the distribution of shoulder width has got to be in context. For boys is irregular in shape, and the female's distribution is more normal, as most female widths are centered around the median. So we have fairly symmetrical data here, and it's reasonably normal, right? Reasonably normal. It's never going to be perfect, but it's quite symmetrical and clustered around in sort of the center area. So that's what we call normal, or you could say symmetrical. the boys or data, that's the females. The boys' data is quite irregular. I mean, I would say it's probably quite a bit like this. We've got bimodal, so it is bimodal. So I would say it's bimodal, right? So female widths are centered around the median. Also, the male distribution is bimodal. So we call it a distribution because that's how the data is distributed. It's our sample. We're only talking about a sample here. This is our sample. And so this is how we do the comparison between the shape. So the distribution of a shoulder width for boys is irregular in shape, and the female's distribution is more normal, as most of the female widths are centered around the median. Also, the male distribution is bimodal. No, that's it. That's all you have to say about shape. Now, more importantly, we get into shifts and centers. So when we talk about shifts and centers, we're basically focusing on the middle 50% of the data, which is the box. We call the box, not a box in statistics, but we call that the middle 50% because that's where 50% of the data falls. Like a box plot, remember, is broken up into quarters. So here's 25% of the data. This is 25%, this is 25%, and this is 25% of the data. So that's why we call this the middle 50%. And that's the most significant when we're talking about shifts and centers. So we talk about what we notice around the shifts, right? And so shift is all about the position of the boxes in relation to each other. And what the shift is one box shift it further to the right, to the left, and so on. So you say the most obvious thing, I notice. Well, what's the most obvious thing that I notice is that male, and we're talking about, I'm not sure what this is. Is this height? Males, I don't know. 41.5, 44, sample size. No idea, could be heights. But anyway, I noticed the male distribution, or the male middle 50% of the distribution is shifted further to the right than females. If it's shoulder width, I don't know, but I'll just say shoulder width. Okay, so I noticed the male middle 50% is of the distribution is shifted further to the right than the female's shoulder width. So that's just the obvious thing. One is shifted further to the right, but you can't stop there. You've got to, besides the the obvious thing, which is the shift, you've got to give evidence, right? You've got to show some evidence around why you're saying that. So then we look at basically the lower quartile and the upper quartile. This is the lower quartile. Oops. That's the lower quartile. That's the upper quartile. This is the lower quartile. This is the upper quartile. So where are those in position to each other? And you can estimate this. It doesn't have to be an exact thing. So male's distribution, or male 50%, middle 50%, middle 50% is between, now that looks like be about 42 centimeters to 6, 7, 8, maybe 48 centimeters. And whereas the female middle 50% is between what's the females? Probably about 38, maybe 39, 38. 5, 6, 7, 8, 9. So probably about 39 centimeters to looks to be about 44 centimeters. So that's some evidence as to the shift. So the male box, the male's middle 50% of the box, shift it further because the lower quartile, and we might even say the lower quartile here, and we can just say LQ is 42 centimeters to the upper quartile is 48 centimeters, whereas the female middle is between 39 and 44 centimeters. So this is the lower quartile. And this is the upper quartile. Now you would write this better than this, but that gets you the idea. Now the other thing that we can do, which is quite nice to be able to do, and this is important for overlap, is kind of look at percentages. Like if you look at the percentage of the male box, so basically this lower quartile, which is about here, it's not a perfect thing. So the lower quartile of the male, lower quartile is about 41.75, and the median of the female is about 41.5. So it's a little bit ahead, but almost all of this box or all of this data here is bigger than this data here, right? So we've got all of that. Now that is 25% is the tail here, and then 25%, which is 1/2 of that box. So that's 50%. 50% is in that green. That's 50% of the female data. Now, this is, in the red here, this is 75% of the male data, right? 75%, because this is 25, this is 25, and this is 25. So that's 75%. So you could actually make a statement here where you could actually say that about 75% of male shoulder width is bigger than 50% of the female shoulder width. So that's sort of how you might be able to sort of say that with a comparison, the shifts, the evidence. Males middle 50% is between the lower quartile, which is 42 centimeters, to the upper quartile, which is 48 centimeters, whereas the female's middle 50% is between 39 to 44 centimeters. And about, don't know why I suddenly start big, but about 75% of male shoulder width is bigger than 50% of the female shoulder width. Now that's kind of significant. We'll talk about that, why that's significant later, but that's kind of the way that you can give the evidence and the explanation for the shift. You don't need that to be so gigantic, but anyway. Okay, and then the centers. The centers are a little easier because the center is just basically where what the average is. So, you know, who's got the bigger average? And we'll look at medians. We can look at means, but this data only has medians. So in this particular instance, the obvious thing is that the male shoulder width on average is bigger than female shoulder width in our sample. Okay, this is a sample that we've taken. So the centers. So that's the obvious thing, is that the male is shoulder width on average is bigger. Now, what's your evidence? So basically the evidence becomes just the difference. What's the difference? So you would just basically subtract. So the male's is 44 minus 41.5 equals 2.5. So there's a difference of 2.5. So the difference in the medians, the average or median, is 2.5 centimeters. Units are important, so that means in our sample, males tend to have bigger shoulders by 2.5 centimeters. Remember, tends is a nice word because it's not an absolute. Not all of them are like that. Just in our sample, it tends to be the case on average. So the difference in the average or median is 2.5 centimeters. So that means in our sample, males tend to have bigger shoulders by 2.5 centimeters. Now, what does this all mean? Because remember, we're taking samples and we're trying to make some sort of inference about what's going on back in the population. Now, this is critical because remember sample variability. Remember that if we take a sample, it could very well be wrong and not actually be giving us statistical parameters that are correct back in the population. So we have to be very tentative about what all this means. What does it mean for the sample? Well, it basically seems to mean that for the sample, males tend to have bigger shoulders, or wider shoulders, if you will. All right. What might it mean for the population? Well, if I was to take a punt, we know that we have to do this very cautiously, but what might it mean? It might mean that back in the population, male shoulders are wider than female shoulders. Okay, so that's just how we do that around shifts and centers and giving evidence. Now, the next thing is you are going to do a little bit of a practice. So you're going to pose a comparative question for the sample here. Shows the times that male and female New Zealand students can stand on their left leg with their eyes closed. Okay? So you're going to pose a comparative question, go back to the question stuff that we did, and figure out what you got to say about these two variables and what are you referring to and the population and all those aspects of the question. Then analyze the sample by comparing shape and comparing shifts and centers. And by the way, I'm just going to put, it's very hard to see, but the medians are exactly the same. If you look at the box, that's not going to show. If you look at the statistics down below, the medians, which is the line here, these are exactly the same. You can't really see the males one very well, but that's what it looks like. They're both the same. So good luck with that, and I'll be looking at that to take a look and see how well you've done.